In this lesson, we will discuss the aircraft general system overview. The 787 aircraft is the most advanced large commercial jet the Boeing ever made. Benefit from the massive new technology and new concepts that put into the aircraft design. The 787 has the advanced flight deck, the advanced technology engines and systems. The advanced wing design includes the advanced aerodynamics and the raked wing tips, the advanced composite primary structure, larger cargo capacity, larger passenger windows, the new wider cross-section that brings the wider seats and aisles, the provision of overhead flight crew and cabin crew rests. Since the longer range and the higher payload in design, the 787-9 have some features that are different from the 787-8. The fuselage lengthened 20 feet, the advanced technology engines with increased thrust rating, the design weight increases, the structural, the landing gear and the wing-to-body fairing have strengthened as required, some minor system capacity changes, larger cargo capacity, etc. Before the 787, the 777 had the most composite construction of any model, but the 787 aircraft uses the composite constructions much more than the 777. The 777 10% composite, the 787 60% composite. The 787 is the first large commercial jet aircraft in the market to use carbon and fiberglass composites for the most of the wing and fuselage structure. The most constructions of the 787 are in those materials below: aluminum, carbon laminate, carbon sandwich, fiberglass sandwich, multiple materials, quartz sandwich. A composite is a material with two or more parts combined together to produce structural properties that each of the materials do not have by themselves. Advanced composites are strong, stiff. The composite engineered fibers are approximately 0.0003 inches in diameter. They carry most of the load. Resin is the glue that holds the fibers together and prevents the fibers from buckling when compressed. Under normal operating conditions, the composites do not corrode. The cracks do not grow in composites as fast as they do in metal. The composites are generally lighter than metal structure. It is also easier to dent aluminum than composites. The 787 Advanced Technology Flight Deck has a lot of instruments, panels, and control assemblies. We will learn and discuss thoroughly in the other chapters. The captain and first officer seats give the flight crew a location to operate the necessary airplane controls. Each seat has two electric control switches, one located under a cover behind the headrest and one located on the inboard side of the seat. The first and second observer seats give a location for observers to monitor flight deck operations. Tracks attached to the floor for the first observer seat. The left armrest moves out of the usual position for storage. The right armrest includes a fold-out work table. The overhead flight crew rest gives the flight crews an area to have the duty shifting rest. The OFCR entrance enclosure module has a door and a stairway with a seat at the top. A door latch lets the flight crew open the door for access to the stairway. The door latch has a key code set by the airline. The OFCR bunk module is for use only during flight. There is one emergency hatch in the floor of the right bunk module aft of the entrance module. The bunk module has oxygen masks, smoke detector, The OFAR entrance enclosure module has a door and a stairway. A door latch lets the flight attendants open the door for access to the stairway. The door latch has a key code set by the airline. The OFAR entrance enclosure module opens into the aft and forward bunk modules at the top. Each bunk module has 3 bunks. There is a secondary escape hatch below bunk 3 on the right side of the OFAR forward bunk module. The aft bunk module has 3 bunks and an emergency hatch in the floor in the middle. There is a secondary escape hatch below bunk 5 on the right side of the OFAR aft bunk module. These are the 3 oxygen systems and the purpose of each. Crew oxygen supplies oxygen to the flight crew. Passenger oxygen supplies oxygen to the passengers and cabin crew for use during an emergency. Portable oxygen supplies oxygen for an emergency or to add to the crew or passenger system. The crew oxygen subsystem uses a gaseous oxygen source to supply oxygen the flight crew at the correct pressure for the altitude. The source of this oxygen is a pressurized cylinder different from the source of oxygen for the passengers. There are 4 oxygen masks in the flight compartment. The passenger oxygen subsystem uses single-use pressurized cylinders of gaseous oxygen. From this source, the system supplies oxygen in pulses to passengers from passenger service units in all areas of the passenger compartment, which includes the lavatories and overhead crew rests. Each cylinder has an attached regulator to supply oxygen to the masks at the correct pressure for the altitude. The portable oxygen system is a set of portable oxygen cylinders on the airplane used to give a mobile source of oxygen during emergencies. There are many portable oxygen cylinders in the passenger cabin. The cabin crew use these cylinders so they can move around the airplane during depressurized conditions. The cabin crew also use these cylinders for medical emergencies. The primary cargo compartment furnishings are the linings and panels that isolate the cargo from other areas of the airplane. The compartment supplies Class C fire protection and keep fire extinguishing agent fumes and smoke from the passenger compartment. These devices also give a closed area for cargo compartment temperature control. They operate the forward and aft cargo door with a handle on each door that locks and unlocks the door. The cargo handling system moves cargo containers and pallets in the cargo compartment. The passenger entry doors give access to the airplane passenger compartment. Each door can function as passenger entry door, service door, emergency exit. There are 4 translating passenger entry doors on each side of the airplane. The passenger entry door mode select assembly is above the hinge arm assembly on the forward side of the PED. The mode select assembly lets you select between normal passenger door opening and emergency door opening. When you put the handle in the armed position, 2 things occur. First, the mode select disarm sensor target moves away from the sensor to electrically arm the EPAS. Second, the push and pull cable turns the girt bar to latch the escape slide raft girt bar to the doorway threshold floor fittings. This arms the slide for deployment when the door opens. The flight deck overhead door is an emergency exit that lets the flight crew go out of the airplane through the top of the flight deck. This door lets the flight crew leave the usual path if they are blocked. The flight deck crew escape door is on the top of the fuselage. It is above the observer seats on the right side of the flight deck. All flight compartment windows are bolted and sealed into position and cannot be opened. Flight compartment windows are transparent and are made of a lamination of glass and plastic. The external window surfaces are glass and have a rain protection hydrophobic coating. The flight compartment windows have an anti-ice, anti-fog conductive heating film. The conductive film gets warm to prevent fog and ice. Temperature sensors in the windows control the window temperature through the window heat system. Passenger compartment window pressure panes are a plug or pressure fit into fuselage window frames. The electrically dimmable window has 2 layers of glass with an electrochromic polymer gel between them. Organic material is suspended in the polymer gel. The window glass layers have a conductive coating on the inside and are bonded together along their edge to seal the assembly. Electrical leads from the EDW switch controller connects to the window glass and gives power to the electrochromic polymer gel for dimming. The EDWs change the windows from transparent to opaque to decrease the light. Control of the EDWs is with a switch controller module below each window. The cabin services system can also control the EDWs.